In lesson 2, we're going to use the number line to model the addition of integers. So we're starting off with a problem that says suppose you received $10 from your grandmother for your birthday, and you spent $4 on snacks. Using addition, how would you write a number sentence that represents the situation? And I've gotten us started by showing the $10 and an addition, because remember we have to write an addition problem, an addition symbol, and then -4 representing the money that was spent on snacks. We're going to model it on the number line, and remember we always start at 0. So we're going to start at 0, and we will go in a positive direction 10 spaces. Maybe not so neatly. And then from that point, counting on, we will go back to the left 4 spaces. And we'll find that we end at +6. And so as we continue, we're going to complete the steps to finding the sum of -2 plus 3 by filling in the blanks. And we're going to model the number sentence using straight arrows called vectors on the number line. We will start by placing the tail of the arrow, the back of the arrow, on 0. Then we're going to draw the arrow 2 units to the left of 0, because -2 is 2 units to the left of 0, and we will stop at -2. The direction of the arrow is to the left, since you are counting down from 0. Next, we'll start the next arrow at the end of the first arrow, or at -2. And we'll draw the second arrow, we're going +3, 3 units to the right, since you are counting up from -2. And we will stop at 1. We can repeat the process from part A for the expression 3 plus -2. And we find that we end on +1 as well. So what can we say about the sum of -2 plus 3 and 3 plus -2? Does the order really matter when adding numbers? Both sums were 1. So think about and reflect on why or why not does the order matter. Looking at example 2, how does absolute value determine the arrow length for -2? Well, the absolute value would be the distance from 0, which is 2. So the arrow length would be 2 units. How does the absolute value determine the arrow length for 3? Again, the absolute value of 3 is 3. And so the arrow length is 3 units. How does absolute value help you to represent -10 on a number line? Well, absolute value tells you how long the arrow needs to be, or the distance from 0 to that number. -10 is 10 units from 0. Exercise 2 asks us to create a number line model to represent each of the expressions. So, -6, if we start at 0, is 6 units to the left. And then from that point, we're asked to go +4. So we would count on from -6. And go 4 units to the right, which would land us at -2. Part B asks us to do 3 plus -8. So starting at 0, we would go 3 units to the right, and then from 3, we would need to go 8 units to the left, which would land us at -5. In example 3, our vectors have been drawn for us, and we're going to determine what the problem is from the vectors. We're going to write an equation to express the sum, and we'll work from the number line position, and we'll work out from there. So the 3 cards that are represented in the model are 5, -2, and 3. We know that because the size of the vectors has been indicated for us, and we know the direction of the arrow tells us whether it is positive or negative. The model differs from the ones we used in lesson 1 because we are no longer doing the hops, we're now using vectors or arrows to determine the length. And making a connection between the sum of 6 and where the third arrow ends on the number line, the third arrow is landing on 6, which is our final total to our sum. Would the sum change if we change the order in which we add the numbers? For example, if we went 2 to the left and then 3 to the right and 5 to the right, would that be any different? And would the diagram change? Reflect on those answers and then get with a partner and play the integer game and use the number line to practice counting on.